Let's take a look at the notes that are on page 9. This section is called Set Representation. Sets can be represented as a list in roster form by a rule using words or set builder notation. We're going to focus on this today. Also in a Venn diagram. For example, you could talk about the set of all primary colors, say red, yellow, blue, and green. The set of all whole numbers, 0, 1, 2, 3, ... That would be in roster form with sets A and B. The rule method, or set builder notation, this is where it's sometimes easier to describe a set in words that gives the membership rule. A set is a collection of things, usually numbers, and we can build a set by describing what is in it. Here is an example of set builder notation. And this is what we're looking at right here. So you might be thinking, what does this say? So this says x such that x is greater than 0. So let's go ahead and take a look and write this down. This is such that colon. That means such that. The set builder notation that you see here reads as the set of all x, that's right here, such that x is greater than 0. My handwriting's not very good, but that's what this says. The set of x, of all x, such that x is greater than 0. X is just a placeholder. It could be any letter. You also might see it written like this. That bar also means such that. It's also typical to show what type of number x is. Here we're being very specific and we're saying that x is an element of reals, such that x is greater than or equal to 3. So that is greater than or equal to. Remember that that symbol means is a member of, is an element of, then this R is all real numbers. So this says the set of all x that are a member of the real numbers such that x is greater than or equal to 3. Or basically, all real numbers from 3 on up. What this would look like on a number line would be you would have your number line. I put my 3 here. It's going to be greater than or equal to, so I have to color it in, and I'm going to need to include and really color this in. This is a heavy bar on the entire number line because we are talking about every single little decimal in between all of those points from 3 on. And then here's something kind of interesting. In interval notation, right here, it would look like this. Now, if you notice, it has a bracket. If you remember from the chart in our room, that bracket means includes. This is saying that it's starting at 3 and it's going in a positive infinity direction, and it's using the parentheses because you can't stop. There's nothing to stop and it keeps on going forever, which is why it's parentheses at the end, because it means doesn't include. Can't include infinity. Okay, on these examples here on page 8, you're going to have to rename the set below into set builder notation or change it from set builder to a roster. So you first have to identify, is this in set builder notation? And because it has the such that and it has the braces, it's got all these words explaining the rules, it is in set builder notation. So we really just need to find out what values are going to fit this rule. So this is the set of x such that x is an element of natural numbers, and x is between 10 and 15 inclusive. So natural numbers are whole numbers, but they don't include 0. It's between 10 and 15 inclusive. So we are going to include 15 and 10. And this would be your roster form. 10, 11, 12, 13, 14, 15. Yes, you have to write them all out. No, you cannot just go 10-15 and call it a day. You have to write them out. Let's take a look at the next one. This also is in set builder notation. And I'm showing you two different ways that you might see it. So these are two different ways. This says x such that x is an element of whole numbers and x is greater than 0. Or you might see it as x such that x is greater than 0 and x is a whole number. We are probably going to be focusing mostly on this. So this is the set of n. That's the name of the set. And its whole number is greater than 0. So a whole number greater than 0. That would include 0. Oops, but we can't because it doesn't say equal to. So we're going to erase that. And we are going to go back and just say 1, 2, 3, 4, ... because it's greater than 0. That's your whole numbers. Number 3. What do we have here? We have a number line. We have to put it in set builder notation. So I am going to call this set A equals. All right, so now we have x such that x is an element of. Okay. We have a heavy bar. Heavy bar means it has to include every single little number in between. What is the number, the vocab word that's going to imply every single one? That would be your reals. Your real numbers. And more specifically, it's asking them to be less than 3, which is why you have an open circle on 3. So this is set A, you can call it set B, set C, whatever you'd like. X such that x is an element of reals and x is less than 3. Things to remember, you must have your x on the left-hand side, or whatever you choose to call it here. It has to be on the left-hand side. Okay, now we have, looks like we have more real numbers, but it looks like there's a limit to what we have. Okay, I'm going to call this set B, and then it's x such that x is an element of reals, but I've got, it's a finite set. So I got to do something a little bit different. I have to show that it's a beginning and an end, and I want to make this nice and simplified, nice and tight. So what I'm going to do is I'm going to look at the smallest. It's a -1, and it's colored in, so it's going to be less than or equal to. And then I have my x. This one's an open circle, so it's just going to be less than 3. So let's see. When you have a compound inequality, and that's what this is called, because your x is satisfying two parts. Here, if you look at just one side, I'm going to highlight this for you. If you look at just this side, this says x is less than 3. And that's right here. X is less than 3. But if you go ahead and take a look at this side right here, this is also saying that x is greater than or equal to -1, and that's satisfying this side. But if you notice, they stop right like that. So that's why you have these boundaries here. And the x is nestled in the center. If you notice, your arrows are pointing in the same direction, because you're going to read this as x is less than 3. But then when you go over on the other side, this says here, if we read it from the x, it says x is greater than or equal to -1, which is true. Number 4 is a tricky one, and we'll talk about this more tomorrow. Last one is 5. Okay, so we'll call this set K. And we'll say that set K is the set of X such that X, what's the most specific term that we have for 5? X is an element of natural numbers, and you can say X is 5. You could also be a little crazy and maybe say 2x equals 10, where you would have to simplify it. But as long as you're getting your value of x equaling 5, that's all you have to do. We'll do some more practice problems tomorrow. Make sure you get all these down in your spiral on pages 8 and 9.